Hello and welcome back to another RealityCapture tutorial. A dreaded problem after rendering is discovering holes in the scan or areas which lack detail due to too few images. And worse, you're nowhere near site, you're back home or at the office and can't just take a few more photos. So how do you know you took enough photographs of a subject for a 3D render? How do you know you shot all the correct angles and perspectives for good coverage of your subject? And how can you check on site with RealityCapture on your laptop before leaving and without rendering the full image? If you had a good answer to these questions, you might be able to avoid having to go back later and take all the images you missed with all the hassle that might cause you. This is where the inspector can help. Let's look at this short video example. I've come back from a shoot, fired up my computer, finished the render, and discovered that I missed a spot or 3 or 4 or maybe a few dozen. You can tell from the animation that I'm unlikely to be hired as a movie director anytime soon, although I promise I fly drones a lot better than I animate in RealityCapture. Now, given what we saw in the render, this means packing up all the gear, going back, and repeating much of the photographic process that we originally went there for. If we use this powerful RC tool, we can minimize trial and error and improve our efficiency in the field. The inspection tool can be used to discover where to add images by determining the weak points of a scene. It can help you identify optimal or additional placement of your camera for best overall scene coverage by analyzing dependencies and overlap among cameras within your scene. Here is its help page in RC. The blue web you see here is the product of the inspection tool. The denser the web, the better. 2 cameras in the web are connected if they have at least 100 matches in common, with those matches visible in at least 3 cameras for consistency. To activate and use this tool within the 3D window, press the I key. It's found under Alignment, Analyze, Inspect. Here's a screenshot. Now let's take the broken model I introduced and inspect it. My model's loaded. I click in the 3D window, I press the I key, and nothing happens. Note, enable Alignment Camera's View to make this work. If it fails to load, check that this is selected and try again. This setting is found at Scene, Alignment Cameras Enabled. Scene, Alignment Cameras Enabled. And I try again. I've pressed I to inspect, and the inspector has built the web. When the tool loads, it appears with default values in the inspection tool panel here on the left, which you can modify. In this example with 110 images, we can see the following. We have good coverage of one side of this model, but a critical lack of data here in the rear. Good frontal coverage, poor rear coverage, meaning we have a lack of data to build a faithful render. We need to shoot more of the sides and the rear to have a complete data set. Since I do have the missing images, in this case I can add the additional images to the project and align it once again. Let's load the completed model with the full 184 images and inspect it for comparison, and then look at a few other scans to see what we can learn from these projects. Okay, so we've reoriented this image. I press I. Here is my inspector. Something to note, because you've seen the entire subject with your eyes doesn't mean your camera has. It's an easy mistake to make early on, and this tool can help us learn more from each project. And this is also why more images are better than fewer images. You can see this web is much more detailed. I've collected far more data for this render. I've got direct overhead shots on both sides, and I have a significant amount of coverage front and back. And of course the one weaker area is this, but in the case of this model, it's not a liability. Now let us have a look at the inspection tool panel and check the overlap density. It loads with a default value of 4 and a maximum of 20. I'm going to reduce this to 1, and we don't see much change. Let me slowly increase this number. So I've taken the overlap count to the highest possible number, and in this case, we have excellent overlap. Now that we've seen the angel, let's take a look at our doll. I'm going to load the inspector. The inspection tool has appeared. Let's zoom out, take a closer look. You can see from this, there is very little overlap in this image, and you can see there's a complete lack of data in the rear quadrant as well as in the lower front quadrant. Also, this upper area is lacking significant amounts of data that could improve the render. The default number is 4. I'm going to scale this back to 1 slowly. We can see from this when I get to 1 that there are additional images, but they have no proper overlap to other images. When I get to 5, this is all that's left. So there's a very low degree of overlap in this image. So we can use the inspector to see that this image can be vastly improved by taking additional photos, or with the existing photos, improving the alignment by changing how we overlap the images. Okay, let's close this one and let's load our cherub. Right, that's our cherub. I think you can tell right away this is a far superior image in terms of its overlap. In terms of the density of coverage, this is excellent. You can see here the way image is taken from the top, looking down at an angle, giving us excellent coverage, even though there's nothing directly from overhead. But also the coverage goes fairly low down, in great contrast to the previous image. We can tell from this that if we do want to add any additional detail, if required, we would do so from directly above. Now that we've seen this cherub, we're going to have a look at our statue of Dante. This is significantly more detailed as well in the doll, as you can see. It's got excellent 360-degree coverage. You will notice though that there is more coverage at the front where more detail is required than at the rear. You can see in this ring of cameras here versus the lack of that similar ring to the rear and to the sides. In this case, that might be a deliberate decision if the detail were required in the front and less emphasis was required for the rear. So this is a region where one could add more detail. Also, there's nothing overhead. I would assume that the only way to capture that data would be with a drone or with a crane. Hopefully from this you can tell that this can show you clearly where you may want to add more data. The closest ring to the rear of the statue is this. It's low down, and the ones higher up are further away. Right, so this can tell us where to concentrate our efforts if we were to shoot more images. And finally, Ananias Chapel. See what you can tell from this. It would appear they started here, went down the stairs, and it would seem they made their way around the walls, ended up in this chamber, and returned. Note that the cameras generally seem to be within a very constrained height range. There is some variance, but not a great deal. Potentially one could shoot lower to the floor, or higher to the ceiling if more detail were required. Perhaps that wasn't the case here. However, this can tell us something about what we're going to get in terms of the final render as to where the detail is going to be, because that will be where the cameras are going to be closest. Objects further away will not be rendered in as much detail. Okay, and that's that. I hope this was instructive. I hope you've learned a little bit about the inspector. I will make a part 2 in showing how we can use this to improve the detail in the image, to realign so that we can get slightly more out of the existing data. I'll leave that for part 2. Thanks for watching. See you next time.